Welcome to part 3 and the last part of the course, domain knowledge. Domain knowledge are the knowledge and experience we learn while working in telco industry. In this section, there are 5 topics that we will discuss. We will learn more about the key organization in telco industry, the evolution of mobile communication, how radio frequency works, signal strength, and cell phone location. First, let's discuss about the key organization. I would like to introduce 2 key organizations in telco industry. The first one is ITU, or International Telecommunication Union. ITU is a specialized agency of the United Nations responsible for all matters related to information and communication technology. ITU has 3 main activities. The ITUO, or radio communication, coordinates the radio communication services and international management of the radio frequency spectrum and satellite orbits. The standardization, ITUT. Standardization defines how telecommunication networks operate and interwork. Last one is the development, ITUD. The development sector drives digital transformation to leverage power of ICT for the economic prosperity in least developed countries. These are the 3 main areas that ITU works on. The next organization is 3GPP, or the Third Generation Partnership Project. 3GPP is an organization that develops technical specifications and maintains the telecommunication standard. 3 main areas covered by 3GPP are radio access, core network, and service capability. The evolution of mobile communication. It's very fascinating to be able to witness how fast this technology has been evolved. Today we simply take the internet and the mobile data for granted. Wherever we go, we expect to be connected all the time. It wasn't the case just 10 years ago. Now let's look at the timeline. In 1980, we witnessed the first generation of mobile communication called the 1G. In 1G, the focus was all about analog voice call. 10 years later, in 1990, we witnessed the second generation of mobile communication, the 2G, and the focus was about digital voice, and for the first time we are able to send short messages called the SMS. 3G was released in 2001, and the focus shifted from voice call and SMS to data and multimedia. In 2010, 4G was released, and it was a game changer for mobile data. We are able to experience high-speed data and voice over the LTE. In the present day, it is 5G. In 5G, it's all about massive connectivity, low latency, ultra-high data rate, and the IoT. The first generation of mobile communication, the 1G, commercially available in 1980, it used analog signal for the voice call. At the time, the call quality was very poor, there's no security, and it's very expensive. Standardization is not there. People cannot make call across different regions, and the phone was very big. The second generation, 2G. 2G was released in 1990, commonly known as GSM. 2G used digital signal instead of analog signal for the voice call. In 2G, we've seen the introduction of the SMS, the short message service. Although data is not practical, the theoretical speed of 2G data was around 40 kilobits per second. In 2G, there's 2 mid-release, the 2.5G, known as the GPRS, and the 2.75G, known as H. Both release focus on enhancing the data rate for 2G. The third generation, 3G. released in 2001, commonly known as the UMTS. Coming from 2G, 3G was a evolution rather than a revolution. But for the first time, we are able to use data services such as video call and web surfing. The theoretical speed of data rate in 3G was around 21 megabit per second. It is the beginning of the new era of mobile phone. This is the birth of smartphone and Web 2.0. 3G also has two mid-release, the 3.5G or ASPA and the 3.75G, the ASPA+. Both of these mid-release focus on enhancing the data rate. The fourth generation, 4G, released in 2010, commonly known as the LTE. It is a IP-based network. We have seen for the first time the introduction of VoLTE or Voice over the LTE. The data rate theoretically was around 100 to 300 megabit per second. 4G also have a mid-release called the LTE-A or LTE Advanced. The fifth generation, 5G. As of 2021, it was released commercially in some developed region. The interface name was called NO or New Radio. The theoretical speed of data rate was around 20 gigabit per second. It's all about massive connectivity, high mobility, and low latency. These are some of the applications of 5G, such as cloud gaming, augmented reality, self-driving car, smart city, and IoT. Radio frequency. You probably already know that our mobile phones signal a radio frequency. In general, higher frequency offer higher capacity over shorter distance and vice versa. In telecom context, 4G offer higher data throughput compared to 3G. However, 3G can cover larger area. Here is the trade-off. When you have higher frequency, you have higher capacity. However, the signal can only travel over short distance with the lower penetration power. Now let's look at the example. Suppose we have a site right here. And this would be the theoretical coverage of 2G with the data rate of 20 kilobit per second. This blue circle would be the coverage of 3G with the data rate of 0.5 megabit per second. And lastly, this red circle would be the coverage of 4G with the data rate of 4 megabit per second. You can see that although 4G have the fastest data rate, it can cover only a small area, and vice versa. For 2G, it has the slowest data rate, however, it can cover larger area. Now let's look at another example. Suppose you are staying in a big building such as a hotel. In this case, your phone probably connected to 3G rather than 4G. Because 4G, although provide higher capacity, it has a hard time penetrate big buildings such as the hotel, which lead to another problem called the bad indoor experience. The solution in this case, obviously, to use Wi-Fi whenever possible. However, another solution is also available. For the operator can deploy small cell or indoor cell to boost the signal of their network. Signal strength. We discussed this in section 2 of the course. To measure the signal strength, we use OSOP KPI. OSOP is a negative value, so the bigger the better. OSOP measure in decibel milliwatt or dBm. Now let's look at the table below. the OSOP of bigger than 75 minus 75 dBm considered as excellent. When you have OSOP between minus 75 to minus 95, it's considered as good. And when you have OSOP of less than minus 115, we consider the quality is poor. And this is the generic threshold. Each operator and each market define their own threshold. And from your mobile phone, you can actually check the signal strength that you're receiving from your operator. On iPhone, to enable the field test mode, you simply dial *3001 #12345 # in the keypad, and then you press call. And from the screenshot, you can see that my OSOP is not great. It was minus 110, and I was simply unable to use the data. Now we have a use case right here. The network engineer measured the quality of signal strength from their end. So the data show that it was, for this particular cell, it was minus 105 dBm. However, when a user check his own device, he see that his signal strength is minus 124. This is the case of experience versus statistic. Sometimes we cannot rely on the network data. It's too optimistic when it was measured at the network side. And it surely can be different when we measure at the user end. So the user may experience worse connection than the data that's shown in the network side. That's why we discuss in the first part of this course the SDK data or third-party data. It's important that we also collect data from the user end, which is from the user device, by using some sort of SDK. Cell phone location. One of the common question is, can telecom operator identify their subscriber location? The answer is yes and no. Yes, the operator can identify the approximate location, basically the location of the cell site that the phone is connected to. And no, the operator cannot get the exact and real location, which is the GPS location. Now let's look at the example. Suppose we have a cell site right here, and a user is staying in this spot, which is along with his or her device. We know that this device connected to the cell. So what the operator can see is the VLO location, basically the location of the cell site. And it's not the user location. The user location or the GPS location are not transmitted to the operator. It's very crucial that we understand this constraint and limitation of the cell phone location. If you Google "is cell phone location admissible?", then you will see a bunch of headlines saying like these two. So cell phone location was misused by people in legal industry and also law enforcement as well. But people start to understand the limitation, and it was often ruled out as it's not accurate enough to be the evidence. And in case you're interested in this topic, I recommend you to read a book called Cell Phone Location Evidence for Legal Professionals. In this book, the author Larry Daniel discussed in detail how the location data was used in court. I really recommend to read. Congratulations, you have reached the end of the course. Let me summarize what we have learned so far. In part 1, we learned about the variety of datasets available in telco operator. In next project, you will be able to use those resources to make better decisions. In part 2, we learned about some of the crucial KPI kept track by the operator. You will be able to understand from how well each component of the business is performing. In part 3, we learn about the domain knowledge. These are all the knowledge that come from real-world experience from someone who actually work in a telco industry that you cannot get otherwise. I hope all of this helped.